I now want to embark on a series of worked examples in the theory of equations. Examples like this have been done already by myself, but just for the sake of annotation, we'll call this particular example as worked example number 1. And here it is. If alpha, beta, and gamma are the roots of the equation x cubed plus qx plus r equals 0, we want to form the equation whose roots are 1 minus alpha over alpha, 1 minus beta over beta, 1 minus gamma over gamma. Now the first thing to notice is that these roots can be written as 1 over alpha minus 1, 1 over beta minus 1, and 1 over gamma minus 1. So let's first of all find the equation whose roots are 1 over alpha, 1 over beta, and 1 over gamma. And this is done simply by replacing x by 1 upon x in the original equation x cubed plus qx plus r equals 0. And that will give us 1 over x cubed plus q over x plus r equals 0. And multiplying up by the x cubed, we'll get rx cubed plus qx squared plus 1 equals 0. So we now need to diminish these roots by 1 to give us the roots that we require, or the equation that we require. And to do that, all we do is divide repeatedly by x minus 1. And I've used synthetic division over here. The coefficient of x is 1. So I've written that as 1 under the letter D divisor, and we reverse the sign of the constant term to plus 1. That's one of the rules of synthetic division. So proceeding now, first of all, divide r by 1, we get r. We now let the multiplier do its job. R times 1 is r, added onto q is q plus r. Q plus r times 1 is still q plus r, add that onto 0, still q plus r. Multiply q plus r by 1 is q plus r, add that onto 1 is q plus r plus 1. So that finishes the first line, and the q plus r plus 1, which I've underlined, will be the constant term in our new equation. We then repeat the process. So r divided by 1 is r. Now we let the multiplier do its job. R times 1 is r. Add that on to q plus r is q plus 2r. Q plus 2r times 1 is still q plus 2r. Add that on to q plus r gives us 2q plus 3r, which I've now underlined. And that will be the coefficient of x. Repeating that again, divide r by 1, you get r, and now let the multiplier do its job. 1 times r is r, add that on to q plus 2r, gives us q plus 3r. And then finally we just have 1 into r is r. And so our required equation is rx cubed plus q plus 3rx squared plus 2q plus 3rx plus q plus r plus 1 is 0, and that completes the little exercise. I hope you understood that, and thank you for listening.